in a circle. Oops, my bracelets are wet. My teeth hurt. All right. All right, how do I find segment lengths? In circles. All right, segments of the chord. All right, what does it mean to be segments of the chord? It's when two segments what's next door? That are created when two chords intersect in the interior of a circle. All it says is this. You have a circle, right? You have two chords intersecting. Does it say anything about where they're intersecting? Just as long as they're where? In the circle. So they're in the circle, they're intersecting. So here's your chords, they're intersecting. All it's saying is each piece is a segment, right? So segments of the chord is the whole chord is being pieced together. Does that make sense? That's all that says. So what does the theorem say? It says the product of the lengths of the segments of the chords is equal to the product of the lengths of the segments of the other chord. There's a couple keywords in this definition. What's one keyword? Product. What's product mean? You're going to multiply. So we're multiplying something, and then what? The product of the lengths of the segments of the chords is equal to the product of the lengths of the segments of the other chord. What do you think that is? Multiplication again. Good? Question? All right, so let's draw a picture. Chord DE, chord AB, DC, make that a C, intersecting at point E. Is E the center? No. Can it be the center? If my chords intersect in the center, it could be, right? Then I have what? What are those chords called? They're going through the center, they're what? They're diameters. But this doesn't say it has to be diameter, right? It just says any two chords can be crossing in the circle. So they're intersecting in the circle at point E. Make sense? Okay. It says the segment of the chords is, this chord is broken up into segments. One segment is E to D. True statement? Yeah, that's a segment. As long as it has two endpoints, it's a segment. And then the other one is E to C. Does that make sense? So that's what segments of the chord mean. So then we have the other one. So, watch what it says in terms of the theorem. The product of the lengths of the segment of the chords. So the product, what does product mean? Multiplication. So multiplying one of the pieces times the other piece, right? Product of the lengths of the segments. So there's the segment of one of the chords broken up, EA and then EB, equals the product of the other one. What do you think the other one's going to say? EC and ED. So we're going to multiply EC times ED. Product means multiplication. Do I have multiplication on both sides? Yeah. Have you multiplied so far? No. You've added arcs, you subtracted arcs, you've divided by 2, right? You haven't really multiplied. So now we're going to multiply, and we're looking at lengths. We have nothing to do with the arcs. We're only worried about the lengths of the chords right now. Got it? Make sense? Okay. Secant segment. What's a secant? What's a secant? How do you know you have a secant? How many times does it go through a circle? Twice. Secant segment. What does it mean to be a segment? Does it keep going? Does it have an arrow? No. Is it a line? No. It has what? How many endpoints? 2. So a secant segment is a segment that contains a chord of a circle and has exactly one endpoint outside the circle. Good? External segment. What does external mean? Outside. So if I'm talking about a circle, where am I going to be located? Outside the circle. It's the part of the secant segment That is, you guessed it, outside the circle. Okay. What do you think this one is? How do you know it's a secant segment? How many times does it go through the circle? Twice. So, and it has one endpoint outside and it's part of the chord. Yes, this is part of the chord. So this is your secant segment. Now, the external segment is a part of the secant segment that's outside the circle. So what piece is that? Where's the secant segment? Top or bottom? Top. It says it's part of the secant segment, but it's where? Outside. So from here to here is your external segment. Okay? What do you think the bottom one is? Has no name, but what do you think it is? Tangent. Why is it tangent? Because what? Touches the circle how many times? Okay. Make sense? Okay. Oh! I just looked right now and reminded myself.
What are we ordering?
It's actually right there on the desk. And then the breakup of the wings is on the back.
Okay. Are we still ordering all of this, even with some not coming?
No, we still have 50 people.
Cool.
Yeah.
If there's a question mark, it says boneless wings, 3 question mark.
That was going to ask you, but we decided, me and you said yes to the 3. So it should be 2 regular, 3. Let's go back to.
Just making sure. It's wild wings, y'all read a tile.
Yes, it is.
Okay.
Look at my G. When you mess up my G. Segments of secants theorem. Okay. We're going to draw the picture, and then you're going to listen. I'm not going to write any words for this one. You understand? Colossian. Colossian. Okay. Ready? My teeth hurt. This is what it says. The segment is secant. You have two secant segments, correct? Okay. This is what it says. It says, if you take the external segment, just listen and watch. You take the external segment, EA, you're going to multiply it by the whole thing, which is EB. So I take the piece times the whole thing. It's going to be equal to the piece of the other secant segment times the whole thing, which is ED. Does that make sense? Write that down. Remember, I said the piece times the whole thing. The piece on the outside times the whole thing. Notice that's the only thing that moved. It hurts. Okay? Make sense? Okay. What happens when I give you segments of secants and tangents? There. We have a secant and a tangent, yes? How do I know? Secant goes through it how many times? Twice. Tangent only touches it the one time. Obviously my circle's off a little bit, but it's fine. Good? Alright. Using the same logic as the last one. The last one said it was the piece on the outside, right? Times the whole thing. Piece on the outside times the whole thing. Now on this one, you have the piece on the outside, but it's also the whole thing. True? Okay, so piece on the outside times the whole thing equals the piece on the outside, which is what? EC times the whole thing, which is ED. Now, can I write EA a different way? I could. I can write EA what? Squared. It's okay. Which equals EC times ED. Do I need to remember that it's squared? No. If that's not how your brain wants to work, then you don't need to. As long as you know it's the whole piece, or the outside times the whole thing. Okay? Now, we're talking lengths. Do you understand? So when I'm talking the whole thing, let's use our logic really quick. Let me lower it so I can write up there. if this is 5 and this is 7, how much is the whole thing? 12. What did you do to get the whole thing in your head? You add. Do you understand? You might want to make note of that because last period was having issues. The whole thing doesn't mean I take 5 times 7. It says I'm adding 5 and 7. That's how you get the whole thing. Got it?
No.
I know. So just
I'll
gonna.
call my calc babies and then I'll be back.
Okay. Okay. Oh, it's not the 15th. It's the 16th. She's yelling. Oh, she's yelling. She's cuckoo for Cuckoo Puffs. Examples. Some of you will have her. Jerk pre-calc. Some of you will never have her. Some of you will have Miss Bright in stats. She also does calc AB. And IM1. God bless you. Some of you had her for IM1. Alright, we got X, 3X, X, and 4X. Okay. Not going to write anything down. Not going to tell you what I want you to find. What do you think you should start with? What you know. Do I care about 360 degrees right now? No. Do I care about angles right now? No. Do I care about arcs right now? No. I'm only caring about the segments of the chords. Okay? So we'll go and try to do what you know. See what you get. Talk to someone next to you. What do you know? Nothing. Wonderful. Wonderful. I just have 3 theorems. You know nothing. That's scary. What do you know? Segment of chords there. What does it say? Product equals product. What are we producting? Which segments? Which ones? VR. Wonderful. Give me a number. I mean a letter. VR times what? V2. Wonderful. Equals? VS times? V. Very good. Who had that? Good. All right. What is VR? Good. What's VT? Good. What's VS? And what's VU? Good. How many of you at least did that? Good. All right. Next. What property is this? Distributive property. What are you distributing? What? 1, 4, 3. What gets distributed? Yeah? Okay. A little scared. What do you get when you distribute? 3x squared, thank you very much. Oh, good job. Woo! Equals the other side. There's no distributive property on the other side. That's just multiplication. Multiply. 4x squared. Wonderful. Most of us didn't get this far, right? I know. You're welcome. What's next? No, can't square root. Combine. You can't combine like terms if they're not on the same side. Subtract what? Good, let's subtract 3x squared. Dun, dun, dun. Minus 3x squared. I'm actually going to write this out because some of us are a little bit lost. This side is 3x equals. Wonderful. What now? Not going to pass the final, guys. Never divide by x. I don't know where you got that from. You can't. There's an equal sign in the middle. Subtract 3x. So what do we get on this side? 0. What do you get on the other side? X squared minus 3x. Now, what do you want to do? Upside down division, which is also taking out a GCF. Upside down division, which is also taking out your GCF. What is your GCF? Wonderful. So I get 0 equals x on the outside. What is left when you take out the x? Very good. X minus 3. Okay. What happens now? Two equations. Very good. Who can guess the first one? Everyone goes for that one first because you don't know the little easy one.
Oh, x divided by x times that. No.
Cover it with x minus 3. Cover it. What do you see? X is what? Equals to, oh my gosh, look at that. Fancy that one. Because look, that's the one, that's the other. Yes? I know. Sometimes I'm smart. X equals what? Equals 3. Okay, now you're sitting here and you're going, well, I have 2 answers. That's wonderful. 2 answers aren't correct. Why? Which, common sense. Which one doesn't make sense? Why? Not because it's 0. Why? It's going to cancel out your x's. If you stick, not even the 3x, if I stick 0 in here, what is this length? You can't have 0 because then you don't have a circle. Understood?
Yeah.
Doesn't always have to be the 0, doesn't always have to be the positive number, that's the right one. Got it? So 0 is not my answer. I do not want it. My answer is 3. Now, that's not the question. Question wanted to know, can you find RT and SU? That's the question. So can you find them? Let's see. Go find them. Did you find RT? Did you find RT? Okay, let's start. RT equals, what is RT? No, I don't want an answer. I still don't want that. What's the variables? X plus 1 plus 3x. Do I need to see work? Yes, I do. I do need to see work. Do I need to see the basic simple expression? Yes, I do. What is x now? 3 plus 1 plus 3 times 3. Now at this point, could you solve? Yes, what do you get? 4 plus, which is wonderful. Who has 13? Good. Do I need to see some work here? Yes, I need to see this and like the plugging in and then the answer is fine. Got it? Okay. SU is what? What are we adding? X plus 4x. You can do this one of two ways. What's way number 1? Add them. What's way number 2? Plug in right away. What do you want to do? Add. What do I get? 5x. What am I plugging in? What do I get? Who has that answer? Wonderful. I'm done with that problem. Let her be. Let's see if we can do it. Do it. God bless you. What should you be doing? Check with someone next to you. Ready? What did you get? How do we do this? How many of you said piece? Times the whole equals piece times the whole thing. Who knew that? Oh, good job. What's the piece, guys? 3. What's the whole thing? Very good. What did I say earlier? You have to add them. What's the piece? What's the piece? 4. What's the whole thing? Yes, I'm going to put 4 plus 2, though, so some people can see it, okay? Could you just put 6? Yes. Some people need to see the 4 plus 2. Okay, real property. Okay, distribute for me. I'm going to combine 4 and 2. What do you get when you distribute? What? Plus? Wonderful. Equals? Wonderful. What now? Okay, so we get 3x equals what? What? 15. What does x equal? 5. Guess what? That's your answer. Who had it? Good job. How many of you put 3x instead of 3 plus x? That's what I thought. Make yourself a note. You have to add. You're not going to put 3 and x again and to put, that's multiplying. Remember that? That's multiplying. Not multiplying, you're adding. So you're putting 3 plus x, not 3 times x. Got it? Questions? Your homework's a worksheet. It's 10 questions. It is based on tonight. We're going to grade number 6. I'm going to pass out the homework, or Diane will pass out the homework. We're going to grade number 6, and you will still have time to start your homework, okay? But I do need the pencils on the ground so we can grade our quiz. Make sure you have a red, just put your notebooks on the floor or whatever, but I need everything on the ground.